Okay, so today we're going to work on lesson 32, multiple step problems in the real world. It's just a part of lesson yesterday, adding in making a graph. So let's just get right into it. Chin is buying beverages for a party that comes in pack of 8. I'm going to circle packs of 8 because that's something that I might need later on in the problem. We're going to let P equal the number of packages bought. And T equal the total number of beverages. And I got that straight from the story right here. Okay? The equation T equals 8P can be used to calculate the total number of beverages when the number of packages is known. Determine, that's our first step, we have to determine the independent and dependent variables in this scenario. Then we need to make a table using the whole number values of P less than 6. So let's jump right into it. Remember, our independent is the one that does not depend on anything else to be solved. So here, the independent is actually the number of packages. Why? Because I can get as many number of packages as I need. What's going to be dependent is the number of beverages I have in all, or my total number of beverages. This is because the total number of beverages depends upon total of packages bought. Okay, so now let's fill in our chart. Remember, T represents the total number of beverages and P represents the number of packages. So if I have 0 packages, T would equal 8 times 0, and I would get 0 beverages. Why? Because I don't have any packages yet with beverages in them. The next one would be T equals 8 times 1, 1 representing the 1 package I bought, 8 representing the 8 beverages in that package. So my total is 8 beverages. Again, replacing the number of packages, now I have 8 times 2 and you get 16 beverages. I'm sure you can look now and see the pattern from 8 to 16. You're adding 8 every time. So just looking at it, the next amount would be 24 beverages. 32 beverages, and 40 beverages. And again, from the story they said, the equation is T being the total number of beverages equals 8 times P. Okay, make sure you have that written down. Now example 1 wants us to make a graph for this. It's important to pay attention to a few things. We always need to label our graph, X and Y. It needs to have a title. This one's going to be beverages for the party. And it's always going to have its origin of 0. Remember, your dependent is your total number of beverages, and your dependent variable will always go on the y-axis. Always on the y-axis. So whatever is your dependent goes on the y-axis. So I can label it here. I'm going to turn it sideways and put total number of beverages. Okay, let me switch it back now. So I labeled my dependent. Now I need to think about my independent. My independent variable will always go, hold on, let me catch up with my writing, will always go on the x-axis. Okay, always, always, always. So your independent variable for this problem is your number of packages. Okay, looking at the table, I can decide the best way of scale for my graph, and I just decided to do 0, 1, 2, 3, 4, 5, and 6 for number of packages. And instead of going 1 every line, I'm going to go by 8 because I know that up here I'm counting by 8 every time. Okay, so 0, 8, 16, 24, 32, 40, and I'm even going to add in 48 even though we're not filling that one in. Okay, so then you just use them like your coordinate plane. 0 and 0 for 0 packages. 1 package, how many did we have? We had 8 beverages. 2 packages, we had 16. 3, we had 24. 4, we had 32 beverages. 5 packages, you have 40. And if you notice, if it is a constant rate or a constant amount, it'll be in almost a straight line. Now, the only difference between this graph and any other is you do not connect the dots. Okay? Not on this type of thing when you're looking at independent and dependent variables. That's it. Hope that helped.